Hello guys, welcome to our course on Python for data analysis. In this lecture, we'll be discussing about understanding NumPy. We will dive into NumPy and we'll try to make an understanding of why we use NumPy in Python. NumPy is one of the fundamental libraries for numerical computing in Python. Before we start, you know what to do. Don't forget to like the video, subscribe to the channel, and put your question in the comment section.
9 to 5 data.
So what is NumPy? NumPy is a powerful library for numerical computing in Python. It provides support for large multidimensional arrays and matrices, and along with a collection of mathematical functions to operate on these arrays efficiently. By using NumPy, we can perform complex mathematical operations with ease and efficiency. So this makes it an essential tool for various fields such as data science, machine learning and engineering, and also all aspects of data analytics like AI and what have you. Before we go into our Jupyter notebook to dive into some key concepts of NumPy and see how we can use it in Python, don't forget to like this video, put your question in the comment section, and subscribe to the channel. So in the previous video, we have seen that NumPy is an external library, and for us to be able to use it in our Python script or Python code, we need to import it. So the first thing we need to do is import NumPy. So let's say we'll say import NumPy as np. Then in NumPy, we talked about arrays a lot because that is what we actually work on in NumPy. So we work with array of different dimension. First, we'll talk about creating a 1D array, a one-dimensional array in NumPy. Create a 1D array. So to do that, we have the array method in NumPy. We'll do np.array, and then we'll give a list of numbers which then translate to our one-dimensional array. So we can save these as, let's say, array underscore 1D. So you can print this as array 1D. So let's try and create a two-dimensional array. We can store that into array 2D and say np.array, and we'll open our bracket. So we'll do our square bracket to store this. So it's going to be in a list. Then we have two lists of numbers. So then we'll do another square bracket again to enter the first dimension, which is, let's say, 1, 2, 3. Then we'll do a comma and do another set of numbers or list of numbers, say 4, 5, 6. So let's try and print this now. 2D. So we can see now that we have two-dimensional array. So and now it's sort of start to look like something like a matrix. So we'll still talk about that. So another important thing we can do is that we can use another method of NumPy to generate an array of zeros. So let's try and do something like that. Say creating an array of zeros. Then we'll do, let's store this in 0 array, and we do np dot. There's a method in NumPy which is zeros. Then we'll then give it the dimension we want. So now we need to try and understand when we say dimensions now. So it's sort of like when we are talking about matrices, when we have 2 by 2 matrices, we have 2 by 3 matrices and stuff like that. And the understanding comes into sense that when we say we have 2 by 3 matrices, then we are talking that we have 2 rows and 3 columns. So the rows come first and the columns follows. So if we say we have 2 by 3 matrices, now we have a matrix where we have 2 rows and 3 columns. So in this array of zeros now, we want to do a 2 by 3 array. So that means we are going to have 2 rows and 3 columns. So we can see that we can say we are having 2-dimensional array where the numbers in each of the dimensions should be 3, or the elements in each of the dimensions should be 3. So if we do now, this takes in the dimension we want, which is 2 by 3, and the dimension has to be supplied in tuple. So we know when we are trying to supply tuple, it should be round bracket. So then we can print this, print 0 array. So we can see now that we have these arrays or this matrix form where every element is 0. So that is about getting 0 array. We also have access to another method called ones, which can help us to generate an array of ones. So let's do something like the top array of ones. We can say ones array equals to np.one, and then we'll supply the dimension we want in tuple. So let's say 3 by 2, and if we print this and say ones array, so we can see now that we have an array with 3 rows and 2 columns. So that's just about ones array. So we can also create a random array, and doing that we use np.random.rand method. So let's say random array. So random array equals np.random.rand. Then we'll supply the dimension we want. So this time around, it won't be in tuple, we just give the dimension directly, which is 3 by 3. And if we print this, we should have random array, which will be in 3 rows and 3 columns. So we can see now. So definitely what you're going to get as a result will be different from mine, because this is generating a random list of array or random dimension of array. Also, we can do arithmetic operation with array. So just like the kind of arithmetic operation we can perform with matrices, because right now the arrays are looking like matrices. The next thing we're going to do is let's create the arrays values we'll be needing to perform our arithmetic operation. So let's say array 1 and np.array. So I'm giving 1 to 5, 1, 2, 3, 4, 5, and then array 2, np.array 6, 7, 8, 9, 10. So I can perform arithmetic operation on this now. Let's say I want to do addition on this, just like matrices addition. So what I'll do is, let me just print array 1 plus array 2. So you can see now that we have just a single array, like still a one-dimensional array. And this is coming from the fact that if you look this in the way we do arithmetic operation in matrices, you can see that the element in the first index add to the element in the first index in the second array, and so on and so forth. So that's why we have 7, 9, 11, 13, and 15, because the last element in the first array is 5, and in the second array the last element is 10. So you add the two together, you get 15. So we can do subtraction also. So we print array 2 minus array 1, just the same way we have done above. Then we get 5 all true. So just like the index elements in each index are subtracting each other, so we do 6 minus 1, we get 5. 7 minus 2, we get 5. 8 minus 3, we get 5. So and so on and so forth. So we can also do multiplication. So let's try multiplication. And doing multiplication, we just say let's print array 1 multiplied by array 2. So we have 6, 14, 24. So just like we have explained before, each element in the index multiplies each other. So we have 1 multiplied by 6, 2 multiplied by 7, and so on and so forth. So we can also do division, and let's do division. To do that, let's print array 1, or let's do array 2 divided by array 1, and let's see the result we have. So you can see the kind of result we have now. So that's 6 divided by 1 will give us 6, 7 divided by 2 will give us 3.5, and we have 8 divided by 3, which will give us 2.6, and so on and so forth. And you can see 10 divided by 2 gives us 2 as a value. So that is division. We can also take one more. Let's take one more example from this, and we can say let's find the exponent. Let's do exponential, like raising the power of an array. So exponential. So to do that, we do print, let's say array 1 exponential 2, and that's what we get. So we get the square of each element in the list. So 1 square is 1, 4 square, and so on and so forth. So that's about the arithmetic operation in array. So just that it follows the way we do our arithmetic operation in matrices. So it's still the same operation that will follow when we use the NumPy array. So we can also do some element-wise function, just like we have done before. Like if you try to get, let's say for example, the square root of the array, square root. So let's say print, let's find the square root of array 1. We'll be using the square root method in the NumPy, and that will be np.square root, which is sqrt, and we'll provide array 1. And when we print that, then we can get the square root of each of the elements in the list. So we can also do slicing of array. We can do slicing of array. So let's say, so let's provide a 3 by 3 matrices. So by using the array, we can do that. Let's say want to do slicing. So the array we want to use, let's name it array 3 and say np.array, and then we would do our square bracket, and the first element square bracket. So since we want to do a 3 by 3 matrices, so in each list we have 3 elements. So the first list we have 1 2 3 followed by a comma. So we'll do the second list, which will be the second row, and then we'll do 4 5 6. So we'll do the third row, which is 7 8 and 9. So let's try and print this to see what we have. So we can see we have a 3 by 3 matrices, and from there what we can do is that we can do some slicing and indexing. And slicing usually is that we want to access, you understand, we want to access some element of the array. So for example, if we say we want to access the first row, to access the first row, we understand that we do slicing in Python. So to access the first row, so we'll do, let's print out the first row. So our array 3 and then square bracket, then we'll provide, just like indexing, so we'll provide the first index. So let's run this. So we can see that it's giving us the first row of the array, or let's say of the matrices. So that is how to access the first row. So also inside the matrices, inside the first row, the first element that we have given, we can see that we have 3 columns inside it. So let's say we want to access the first column. How do we do that? So to access the first column again, we can do that by also doing the slicing. So first column, so we have the first row now, so we want to do the first column. So we'll do print array 3, then we bring our square bracket. So we want to access the first column. So for us to access the first columns, that means we need to access all the rows in the matrices. So now we just do column, the column icon, and do comma, and then we now provide the index of the first column, which is usually 0, and we'll do that. So what this statement is trying to tell us is that we want to access all the rows in the matrix or in the array, and after we have accessed all the row, then we just need to access the first column. So let's run this and see what we get. We can see now that we have the first column now is 147, and if you look at the way it is, the first row we have 1 starting for the first row, the second row we have 4, and the third row we have 7, and going down vertically, that is the column. So the first column is 147, so that is what we have here now. So also we can do something we call sub array. So let's say, for example, we want to access the second and the third column starting from the second row. We want to access the second and the third column starting from the second row. So basically what we're trying to do is that we want to get 5 8 and 6 9. We want to get those two elements. We want to get 5 8, which is the first column, and 6 9, which is the second column. So the way we do it is that we do sub array, or with a sub array. We're also going to do indexing, but right now we do something a little bit different from what we have been doing before. So let's print array 3 and open our square bracket and close. So in the row now, in the row we have to specify the rows we want. So the rows we want to access is the second row, which will be the first, which will be index number 1, So we'll do index number 1 and column. So after that, we can specify the endpoint, but since we want to access from index number 1 to the rest of the elements, so we don't need to specify any ending point. So we just put a comma then to specify the column we want to access. So the column we want to access is from the second column to the third column. So we do the same thing. The second column is at index number 1 or so. We do 1 and then we put a column. So definitely if we give a number, then we are giving a stopping number. But if a number is not supplied after the column, then we are saying we want to access the rest of the column. So if we print this now, we should have the 5, 6, 8, 9. So you can see now that we have the array. Now we have the 5, 6, 8, 9. So that is how to do the sub array to select some specific array. So it's just by doing the proper slicing and indexing. So another thing we can also do with NumPy array is that we can reshape NumPy array. So what we mean by reshaping is that once we ask for the shape of an array, we are trying to ask for the rows and column. Just like the array 3 that we have is 3 by 3 array. So that is the shape. Once we say, okay, what's the shape of the array? We say 3 by 3. So it means it has 3 rows and 3 columns. So then we can change the shape by saying, okay, we want to change an array from a particular shape or from a particular rows and column to another shape, which will also be a different dimension. So for example, we can reshape our original array. So let's try to reshape the array 3 that we have. We want to reshape it. So let's print array 3 again to be sure we still have it. So our array 3, we can see that is the 3 by 3 matrix. So we can reshape it into 1 by 9. So if we reshape it to 1 by 9, so we are saying we want an array with 1 row and 9 columns. So let's try to reshape it. So we can do reshaping by having access to the reshape method in NumPy. So we want to do 1 by 9. Let's say reshape to 1 by 9. So we'll do print array 3 dot reshape, and then we'll supply the shape we want. We don't need to supply this in tuples, so we just supply it normally. So 1 row, 9 columns. So let's see what we have. So you can see now that our array 3 has flattened out and it's now 1 row and 9 columns. So that's about reshaping. Also, we can do matrix multiplication in array by saying we want to do like dot multiplication like we have it in matrix. So let's do some array. Let's have 2 arrays, 2 by 2 array. So let's say a equals to numpy.array and we'll supply the 2 by 2 matrix 2 by 2 and say 3, 4. So this second array, which will be B, we'll do np.array and then we'll say 5, 6, 7, 8. So let's run this. So using dot multiplication, so we can do print np dot, which is a method in NumPy. Then we supply the 2 array as the argument, and then let's run that. So we can see what we have now, the dot multiplication. So I won't be going into detailed explanation of how this come into play or how we got this result. So if you understand matrix multiplication, then you understand how we have come about this result. So that is matrix dot multiplication, and it is a very useful method when it comes to data science, because most of all these machine learnings are usually transformed into arrays, so where we need to do some matrix multiplication and inversion and stuff like that. So we have come to the end of this course, and we have seen how we can use NumPy in Python. Like I told you, NumPy is a powerful library in Python because of its ability to do a lot of things, especially calculation wise, and it helps to perform linear algebra such as matrix multiplication, matrix inversion, and even a lot of things you cannot imagine, especially in linear algebra operation. So we have come to the end now, so don't forget to like this video, subscribe to the channel, and put your question in the comment section. Happy coding.